Okay,
Can you see my
perfect. We
screen?
can see. Absolutely.
Thank you very much. Okay, so our project is about best measures for financial success, and the team included Deepika, Vikram, and myself. I'm going to cover the agenda, what I'm going to talk about. We gathered the team, we chose a topic by vote and planned the project approach. We used k-means clustering to address the problem statement. We also covered the libraries we used, the challenges we faced, and the lessons that we learned. In terms of problem statement, the big question we are trying to address, also in the title of this presentation, is which majors provide the best monetary gain. The data that we used is based on a year-long survey done by PayScale on 1.2 million people and published in Wall Street Journal. The approach that we used was to clean the data set, do clustering via k-means, and generate a PDF report to visualize the results. In terms of project planning and implementation, we assemble a team fully committed to the project and bound by our ground rules. We assembled the team of 3 members. We had each team member propose a data set for the project. We chose the data set by vote, and then we assigned the roles and responsibilities for the project. We also set up upfront the ground rules, and we agreed upon before starting working on the project. Communication channels included WhatsApp and Zoom. Repository was Google Drive. And the most important thing was to plan minimal meeting time via 15 minutes daily Scrum at 6 p.m. just before the classes, every day, every working day for 2 weeks. We had prerequisites to join the class, and we have active presence via daily deliverables, both code and project. In terms of who did what, pretty much we had almost equal contributions. I took care of the problem statement, project planning and implementation, web page harvesting, a new library not covered in the class, and PDF reporting at a high level, of course. And Deepika took care of the dataset cleanup, k-means clustering, and Vikram took care of visualizations. They were in charge, but we all contributed to the code more or less equally. Deepika, please.
Yeah. So this is how our dataset looked like. Our dataset had 150 records and 8 columns. As you can see, each row is an undergrad degree with its associated salary values. So the salary values in our dataset were of character type and had dollar symbols and commas in them. We had to omit the dollar symbols and commas using the gsub function, and all values were converted into numeric type by using the as.numeric function. The third column in our dataset was a calculated column and was not required for our analysis, so we assigned it to null.
Before making our clusters, we made a graph to analyze the data. We decided to examine the median salary graph to see which major has the highest salary versus the lowest. In this case, it's chemical engineering that provides the best financial gain. And we have religion as the lowest one that provides minimal financial gain.
So we ran the k-means algorithm for the starting median salary and mid-career salary values of percentile 10, 50, and 90. As you can see in the scatter plot, the number of centers chosen was 3. The green cluster is the cluster with the best payback, and it contained mostly engineering degrees.
Our cluster analysis revealed 3 distinct salary groups. The first one being lowest paying degrees. In this case, it would be liberal arts degrees. Then we had our second cluster, which would be moderate paying degrees, such as business and finance. And finally, we have the highest paying degrees, which were all in the STEM field.
In terms of libraries, we use several, some of them not covered in the class, and they are listed here in alphabetical order by library name. It includes data manipulation, such as dplyr, several graphics libraries, FactoExtra, ggplot2, graphics, GridExtra, web page object harvesting, rvest, and statistical k-means.
During this project, we faced some challenges. I was struggling with a few plot creations and determining which plots were actually relevant to the project. Deepika had issues with a few clustering functions. As for Dan, he took out the challenge of assembling the group. Luckily, we were able to work through these issues as a team.
Some of the lessons that we learned with respect to this project were it's always good to write simple code with proper commenting so that other members can understand. Any code snippet should be tested for correctness before integrating with the main code, and after integrating, the entire code should be checked for correctness. With respect to teamwork, it's always good to take up tasks as per the members' strength and skills. Any problems faced should be resolved quickly by discussing with other members, and it's always good to give input on work done by other members.
In summary, we were able to find out quite a bit of things. Firstly, STEM degrees in engineering and computer science seem to yield the highest salaries, between 60,000 to more than 100. Then in the middle, we have business, healthcare, and communications. They pay around 45 to 60,000, whereas we have the lowest paying degrees as, once again, liberal arts, from 34 to 44,000. Now, I'll pass it off to Dan for a live demo.
So we want to prove that what we did is our work, and pretty much this is the code that we work on together on, which is shared on Google Drive. I'm going to select the code and I'm going to pass it into a clean environment of RStudio. And I'm going to run it, and I'm going to generate the report in the folder, CData folder, that is in the upper left corner of the window. A file is going to show up in there once the code starts. I'm going to give it a run right now, and you see the file came up, and the file that is generated should include the 3 graphs that were shown in the class. And that's our project.
Guys, give a big round to this group. First of all, awesome work. And I would really say that you have a very good team transitions as well as good teamwork. Everyone had a very clear voice, and I can see the confidence in your voice shows clearly that you all contributed in your specific part. I have a few questions. Can I ask?
Yes.
Okay, so first of all, when you did this analysis, and I think the last slide our Vikram was presenting about the summary slide. So Vikram, when you are sharing, like, there are 3 categories. I think there is a salary range you have, right?
Yeah.
So when you, what do you call, extract or summarize this data, how confident you are that this information is correct and the audience take this message home? Or do you have any data evidence or any other way you can prove that, yes, I validated this summary is correct, that stamps makes highest salary?
I believe that this data is actually fully correct. The source was from a reputable source, and even plotting it on a few graphs was able to provide us like what exactly were the ranges, and obviously the cluster plots helped out too. So I have no doubt that there was no issue with the data. The only thing I guess you could say is our data set doesn't have location, and obviously salary is different in a lot of locations. Like STEM could be like 200,000 in California because it's super expensive to live there, whereas like Illinois it's like 150, because it's not that expensive. So that's like the only thing to, I guess, look out for in a way.
Yeah, so
So
Vikram, like you kind of answer what I was looking for. Because you do not have a location, how would you take this summary and apply? So example, you're presenting to me, I'm in Chicago. Am I getting the wrong data? Because this data might be for Australia or maybe for Chicago, California, and you're presenting to the audience who are in Chicago. How do you apply data collected from location A and the audience is location B? How can I take that? Is there any correlation or what do you call some kind of way you can say, okay, it works in this location this way. However, you are in this, you might be in this range. Did you ever think about that?
We didn't have any
I actually
location though. We just have majors, salaries. So we didn't have any location. So if you look at, let me see, I think this is one. So this is the major table. So it's just the major's name and then salaries, no location.
No, I understand. I understand
Yeah.
your data did not have location, but as a data analyst, you may have a question, right? Without location, if you remove the location, because that's your easy language driver factor, right? If location is removed, then if we analyze this thing and we come up with some kind of summary or conclusion, right? Would that be appropriate?
I think based on our results, as I said, was correct. I'd say it's more of an average from all states since there's no since there's no actual location. So if I was actually talking to someone who was based in like California or Chicago, I'd also want to adjust the salary values to cost of living and like expenses and everything, because I'm pretty sure there's a way to actually calculate that. So if I added those calculations into obviously a data set as like a few examples, I believe that would solve that location based issue.
Excellent. Excellent. Could you go back to that grid which you were showing? Is that number is correct that you have only 50 records?
Yeah,
Slide number 6,
50.
I believe. Slide number 6.
Okay. Slide number 6. Okay.
We have 150 records, Tushan.
50 records on 50
Oh,
majors.
sorry, 50
pretty much.
records and yeah, 50
Majors.
majors.
Oh, so each major you have 50 or just total 50?
Total 50 majors.
50 majors.
So data set consists 8 attributes, which is the column. When I hear 50 records, I'm assuming 50 rows. Are we saying that 50 rows here?
Yes.
Yes.
So do you think that sample is pretty small? Because
no, I think yeah, the
Sorry,
data set was already sort of managed by Wall Street Journal. Imagine they had 1.2 million people providing information from PayScale. So we just took that data because that was the only thing. They did not provide anything related to the actual 1.2 million records. So probably that might have had location or whatever, but we just took what we had, and we have the link. So, but it's just 50.
Perfect.
50 majors.
Got it. So now maybe anybody can answer. Can you go to slide number 9? So in slide number 9, you have like a 3 cluster, and I think when Deepika you were explaining about that, hey, you used 3 centroid or center
Yeah.
and came in, right? Why? What was the what do you call reasoning behind selecting 3 cluster?
So in RStudio, we have a function fbis nb cluster with which you
Uh-huh.
can find the optimal number of clusters. We
Uh-huh.
choose the within sum of squares method to
Uh-huh.
find the optimal number of clusters, and we plotted the graph of k versus the within sum of squares,
Uh-huh.
and the elbow of that graph
Uh-huh.
would give you the approximate number of optimal clusters. With that, we found that the number of clusters could be 3.
Wonderful, wonderful. Very good answer. Could you go back to the slide? Yeah, I can see there are a couple of outliers. Did you ever think about to remove those outliers? Would it change your result? Because I can see green and red explicitly shows as an outlier. Did you filter it and try to recalculate your summary?
No, we did not.
We did not.
What do you think?
I mean, we covered quite a lot of topics and we removed quite a lot of graphs to keep it within the time limit. We had about 6 or 7 graphs, but we decided to see what is the most relevant. Do we have something consistent? But I agree with you. I mean, it can be evolved. We don't have any location data, but going further, refining based on the outliers and so on, I'm sure we can generate more. As you could see, if you look at the code, we had look at the how many lines are commented out, and they were providing 4 or 5 extra graphs that we did not put in, because we decided what is the most relevant that we can fit within the 10 minutes.
Perfect, perfect. Now the last question. Overall, did you guys have fun?
Yes.
Yeah.
We have.
When you especially work on a subject which is something sometimes it's a completely brand new, when you work with a brand new team, creating a bonding, coming with the scheduling and all, was it challenging or it was easy ride?
It was not easy right at the beginning because we needed to agree with some ground rules, and then we had to stick by them, and once we stuck by them, everything was easy flow.
Excellent, excellent. Let's give a big round. Wonderful question answers, so thank you so much. I hope you enjoyed. These are the way people will ask questions, so I just wanted to give you the idea that anything you do, try to go back and think about it, because trust me, your inferences will help decision maker to make, I can give you without any hesitation, millions of dollar decisions. So they want to be what do you call extra careful. Are they making a right decision or with biased decision? So that's the reason more question you may gather when you're presenting. Trust me, we have limited time, so we can't go forward, but you got an idea that this kind of questions you may expect. But thank you so much. Awesome work.
We used, it's a life expectancy analysis. It's 4 of us. Eva, Dev, Nev, and Ruchi. And we were studying the factors what would affect the life expectancy all over the world. So basically, the main question was what variables are actually have a most influence to this, because this topic is quite interesting, and a lot of governments and private sectors, they do need know these factors. So data was straight from the World Health Organization. We have like 22 columns and almost 3,000 rows. I believe it's 193 countries, and the year range was from 2000 to 2015, so 16 years of data. Then I just started cleaning and transformation. So we've checked for the missing data, and it was a lot, like almost 44% data was missing. Then we've checked where it was. So the most missing categories was population, hepatitis, GDP, total expenditure, etc. Then using this box plots, we find out where outliers were. So the most missing values again was in population, etc. So we transform the data using the imputation. So we calculate medians for the high outliers and calculate mean for the low outliers, and basically change it, and also replace NAs with this mean and median values. Then exploratory data analysis comes. So basically, most of the features in this data is continuous, and some of them are categorical, such as status of the country. It's either developed or developing. And when we run the code, we can definitely see that the developed country has a much more life expectancy. So it's like a valuable factor for us. Then we run a correlation matrix. And after that, we can see that some of the features have a strong correlation between themselves. So it's calls, I believe, collinearity between those features. So I've checked some of them with the variance inflation factor as well, just to make sure. And this factor, variance inflation factor, was some numbers were above 5. So I removed what was larger than 5 and keep the rest. So we ended up losing 3 features there. We delete under 5 days, GPD, and thinness in this data. So, and run matrix again, and we see that this collinearity is gone, and we can continue with the data set, and its data set will name model data, model EDA. Then basically I have 5 models. It's not all of here, so I don't want to bother you with numbers. So I created 5 models, and I run them through the system. It produces some crazy looking numbers and 4 pictures. You can see it here. So check all these pictures and numbers. I kind of can see that data is not really good. It's okay, let me rephrase. It's not perfect, but it's suitable. So adjusted R-square, it's around 0.7, 0.8. So I'm kind of okay, I will go with this. Linearity assumptions all met with all 5 models. All these graphics are also runs kind of normal. So we proceed with this. And there is one example how it looks like with numbers. And a fun part, we can see how it reflects our life expectancy. And interesting fact that infant deaths, alcohol, and BMI, and schooling, of course, have a positive effect on the life expectancy. And again, surprisingly, immunization and hepatitis has negative effect on the life. And again, surprisingly, GDP doesn't have basically very small impact of this. So I was surprised, especially with alcohol and GPD. And alcohol has a positive reaction for the life expectancies. That's really good. So let's go here. Here's my 5 models. Well, where's all numbers? So the last model kind of 0.8, so kind of the best. So we can see that adult mortality, HIV, infant deaths, under 5 deaths, schooling status, income composition of resources, and BMI has the most affected factors on these models. And again, recommendation. So wherever a private sector or government wants to have these numbers, because, for example, medical field, healthcare, insurance, government relation pensions programs, they all need these numbers in their hands so they can either improve it or opposite, you never know. So that's it for the PowerPoint. If you would like, I can show you the our program.
Sure.
I don't know if can you see it, or I need to share?
No, we are able to see thank you slides, so you may want to stop sharing and start sharing with RStudio.
Okay, let me find out. Okay, here, RStudio, share. Can you see it?
Not yet. Yeah, now we can see. Yeah, we can see.
Okay. So, okay, guys, there is a lot. So, there is a lot. I don't know what you want to see, so I will go just with pictures. You probably can see better than an PowerPoint.
Absolutely. This is a lot more work. I can see that. Seems like you have 488 lines of code.
Oh, yes, it's a lot. I had some extras I didn't show. It was like a simple linear regressional. I didn't include it because it's kind of extra. And I did mail. Hold on, where is it? Out the email without attachment. I swear it worked, because this code, it worked and it stopped. It worked here again. There is no package Java home. I installed it again like 15 minutes ago, and now no. But before that, it worked. And I have another one cool feature, but again, it doesn't work now. I create a map. So I basically create a word map on RStudio, and it shows average life expectancy per each country. Of course, it was a mess. It's not a Power BI where you can, zoom in, zoom out. But still, I was surprised. But I'm sorry, guys. It stopped work for me this evening, but it worked before. If I'll reactivate it, I'll share it.
No worries. So first of all, Eva, seems like everything you did by yourself, or you had some team member in your group?
Yes, I had. So there was 4 of us. I believe for about a week, we had a meeting every weekend or every evening to discuss this. So we start together, kind of share the ideas, how we will go, share what kind of direction we will go, because
so did you guys had like some kind of a disagreement initially, what subject to take and what data to select, or everyone anonymously agreed with that life expectancy data?
Agree, because it was my suggestion. Sorry. And I throw it in the beginning that I want to use this data.
Okay, so first of all, looks like excellent work. I saw during your presentations, you use various statistics and analytics words. And not only you use, but you also demonstrated correlations. You also showed outlier. You also saw filtering part, and there are many linear regressions, and there are many more. Now, the question I have is, when you select this data and you kind of started, especially last slide, you were saying certain factor has a positive effect and certain factor has negative effect, right? Do you think that statement has some error? Because that statement may not be true for all country equally.
Of course,
right?
Yes.
So when you say that, do you need to also qualify a little bit extra that looking this data, certain country means this country, like maybe you can create a cluster of country who has similarity effect and certain country has D. So your audience or your listener may don't take a wrong message. Otherwise, what will happen? People may think, oh, this is applicable universally, which seems like not the case, right?
Yeah, it's understandable, but we did completely work on modeling. So I create 5 models to test, and that's it. I understand that this data is huge, and we can dig in like a lot. We can split it by continents, by countries, but by years, by specific features. So yes, there is a lot, and I believe when I look at it really quick, for example, these factors like alcohol. It has positive effect, and my model is proofs that it has positive effect, like overall from the whole world. But if we'll go deeper, in Africa, it has negative effect.
Correct. And that's what I thought. And one thing I'm curious, like when you were trying to show one of the correlation graph, you said that I remove, filter out 0.5 or 5, something you said. May I know how you define the business rules that I don't need this, let's remove it?
I'm sorry, could you repeat it? What?
In one of your slide where you were showing correlation and you said, you know what, I remove 0.5 or 5, and then you said, now it looks much better. So how did you come up with those business rules? What triggers or what helped you to derive such kind of business rules?
I remove the like you mean variation inflation factors from the model?
Yeah, you did, right? So
yes.
How did you come to know that I should remove 0.5, not 0.2, not 0.1?
Hold on. If I can find it. No, I cannot find it. There was some kind of statistical formulas, if I understand the question correctly. There was a statistical formula, I would say, where you can check it. For example, even on this correlation mix, we can see, hold on, let me see it myself. For example, GDP has this correlation, high correlation with the percentage expenditure. So it means that they really kind of reflect to each other. So they really repeat each other. And in the model, in a linear model, we cannot use such attributes, such predictors, because they might ruin our model. We need to get out of it, because it will not be a correct model. So I can see from this correlation matrix that there is 3 of them, and then I run the variance inflation factors check. I don't have it here. I have it separately. It's also some kind of mathematical statistical formula. So they show us in numbers which factors has what number. And those 3 guys had like a lot, like, I don't know, 15, 19. And the rule is if it's over 5, it really has this collinearity between them, so we cannot use it. We need to do something before continue. So I just omitted, and I omitted those factors in one model. So total I have 5. So in some other models, I used some of this.
Got it. And you have seems like use various library. So what are the, first of all, how did you start finding those library, and what triggers you to use certain graphs or certain library?
Libraries, like, I don't know, like kind of Google it. So I need, for example, I need this formula. So I start doing this formula. It doesn't work. So I like, okay, Google it. And most of this, it's really quick and easy to find out. The worst part was with email, with sending email. It took some time. And the even worse part with this map, which I cannot show you to you guys today, because I installed a lot of libraries, a lot, and they start to conflict to each other, and it's a mess.
Got it. Got it. But overall, let's give a big round to this group also. They are also doing amazing job. So thank you so much, guys.
So my project is on diamonds. We have 3 members, Matthew, Michael, and Murthy, myself. So the main goal of this project is determining the price of diamond. Are you able to see both screens or one screen?
One screen. Right now, we are able to see determining the price of the diamond, which is good.
Okay,
You may be able to see
Yeah.
two, but we are able to see one, which is right.
Yeah. So the price means in determining the price of a diamond, there are various factors. And which factor is good? That I want to find out. And which variable is most important? Which variable is not important? That's what I am trying to find out. And basically, these are the dimensions for an idea of a diamond. Everything goes like this, depth table like this. In the second, this is the X, Y, G, and just to have an idea. So I have a data of 50,000 diamonds data. And that is, the variables are price, carat, cut, color, clarity, X, Y, Z, depth, and table. And I have definitions for each of everything. And the price is ranges from 326 to 18,823, like that. So I took the data in R. It is called tibble. I got it from tidyverse. I installed tidyverse package, and this is available in R database. So you can see here the table has 53,940 rows, and these are the 10 variables: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I used R to make. Previously, you can see all are lowercase. First letter is lowercase. So I changed it to first letter is uppercase. Then I removed NA values, cleaning of the data, and I removed zeros and everything. Now you can see those became 53,910. 20 rows got removed in cleaning process. Then for each variable, I prepared box plot to find out outliers. These are the box plots. For example, 4, I have several, but I didn't display here. With outliers, the second one, I removed outliers, and this is the outcome. And I prepared and also here, there are the different kinds of variables: categorical, numerical, integer. And categorical variables are cut, color, and clarity. These 3. And numerical variables are carat, depth, table, XYZ. And integer is the price. But here in this analysis, we used price as a dependent variable because we wanted to find it out. All other data sets are independent variables. So I am we are attempting to predict the price of a diamond based on its other characteristics. So in this process, we thought numerical data works best for simple regression. So we focus more on numerical variables. This is the combination of R values for all combination of numerical variables. Here in this, I see caret has a strong relation with X. Depth and table don't have any relation. Price has relation with depth, Y, G. Here, I'm sorry, it got mixed. And X has strong relation with Y. Y has with X. G has with X, 0.8X. So first thing is depth and table don't have any relation. That's why we thought of removing depth and table from the analysis. Second thing, out of remaining 4 parameters, we can choose any one. We thought of taking only one. So we thought of selecting G for our analysis purpose, so that how price varies when G varies. That's what we wanted to find out. So first step in this analysis is we created a regression model to split the data into testing and training data sets. And now I will go to R to show you. Here, this is how I found out box plot for outliers. And you can see after removing the outliers in box plots. Then here we created a model, and here we got a coefficient and intercept. And here M is the in Y is equal to mx plus b. That is the formula for the slope. So here M is the coefficient, that is 46, 41, and B is the intercept, that is 126.06. So we used those values in calculating price for G value. So price equals 46441 times G minus 12606. So to find this, we developed we used this ggplot and geom function. So if I run this, I got the scatter plot with G values. Actually, this code plots series of equations from y is equal to x to y is equal to x power 7. So this line is looks to be perfect for our analysis. That's why I made it, I changed the value to 2 here. So it became thicker. So this value is x power 6, I mean g power 6, that one. So hence the equation for the price and g of a diamond, we concluded as price equal to g times g power 6. That is our conclusion. So if that is one of the factors with respect to g varies by 6, that is the ideal price for diamond. That's what we found out from this analysis. So in this analysis, we used several libraries like, and we faced a problem while doing because of sometimes the libraries didn't work. We repeatedly installing libraries, that kind of thing.
Very good. So Murthy, first of all, thank you. This is like very interesting, what you call subject. Diamond, who doesn't want to know more about it. So could you help me? What is your G value? Because I see you are referring Z as a column,
Yeah.
and you're predicting price. So I could not catch what is Z here.
G is the total height. So if total height varies, the price depend. One of the factors for the price of a diamond is this one.
Oh, I see. So you're saying that is if the Z value changed, so price changed. So you are seeing a strong correlation between Z versus price, and then you're based on that, you're doing regression. Am I right?
Yes. Yeah.
So how did you prove that? Could you go back to your correlation table? Sorry, I was focusing on color and seems like I missed that. The PowerPoint has, you had a PowerPoint, right? That you highlighted green color and red color in your PowerPoint?
No, actually, I didn't show much in my PowerPoint.
In your PowerPoint, there was a table. Yeah, the table. Yeah, this one.
This one.
Yeah, and here
Okay,
price.
depth.
Yeah, I can see 0.87. Yep. So
Yeah.
you're showing
the
price.
XYZ. I'm sorry.
Sorry, continue.
XYZ all have almost equal strength. That's why. So randomly we choose G.
Would it better that you also do the similar thing for X? Means price has a relationship with Y. What happened? Price because
Yeah.
These are different factors, right? And did you try multi-regression?
That's correct.
Means did you try multi-regression, like, because each factor individually you do?
Yeah. I thought of it, but I am afraid of time constraints. So I may exceed the time. That's why I didn't go for it. I tried to limit the content.
No problem. But do you agree that, like example, if I have a salary for a job, one factor is education. Higher the education, higher the salary. But that may not be the only driver, right? Experience may be the driver, expertise may be the driver. Same thing here. Seems like there are many drivers because of correlation values are very high, right? So in order for us to predict, maybe we can consider multiple factor and see X has a definitely positive factor, but collectively X, Y, Z I will be more precise in predicting diamond price.
Yeah, exactly. I do agree.
Yeah. Could you go back to
Yeah.
your RStudio? One thing I could not understand, you're using square, cube, and power. How did you come to know about that you have to use the function of x square, x cube?
Randomly, we choose this kind of mathematics. So if simple G,
Mhm.
no power, how it works?
Mhm.
So x square, how it works? X cube, how it works? So it is a kind of hypothesis.
Okay, so that's just a hypothesis. And
Yeah.
the original color which you have, which one is the color? Original color is the blue color, right? The geometric point x versus price, color equal to price, and color equal to price. What is your color
Yeah.
equal to price means here?
Originally, if I remove this, everything is black. So because I thought it will be good if I display instead of black, I thought of displaying a different color.
No,
That's
that
why I
is
put
good.
this.
Got it. No, it looks good. Your graph really helps a lot to understand where you are having a more positive thing, and you use size too, which kind of helps focus on that. I was just curious how you came up with this square, the cube, and all. Good. So one more question.
Yeah.
When you were working with your team, like, did anytime anyone think about that, hey, let's do this way or that way about diamond analysis? What other ideas you had while you had because you had a significant data, right? 50,000+ records. What else you and your team were thinking about to find out?
Actually, this project looks like every day we don't know how it is going to end up. Every minute the idea is changing, and at one point I thought, why I took this project? I could have gone for a different one. So finally, because of time constraints, I finally decided to go this way to do the project.
No,
So,
this is wonderful work. You should be proud. You and your team should be proud. The work is done awesome. There is nothing wrong in that work. Sometimes the content is new for audience, and I think you did an excellent job to walk through what are the drivers, what are the dependents, and what are the things are there. The only request I have is when you are presenting, and it applies to all, when you are presenting, audience are listening, and if you don't speak for a few seconds, they will think there is audio video issue. So you have to continuously give commentary. You have to continuously give commentary. Let me show you how it works. Let me do this. You might have seen me 3 hours continuously I speak.
Yeah.
Right? Because that's we call it distance learning problem, right? If you don't speak, audience will lose. So overall, awesome job. You and your group must be enjoy with the diamond, and I'm sure now onward you will definitely check for the height of the diamond before you look for the price. So thank you so much. Let's give a big round to this group. Now we see. Yeah, it's coming. College football. Yeah.
Okay. Still good?
Yep.
All right, thank you. I made using linear regression, a model to predict college football games for the 2022 season. And we'll find out along the way how well that went. So the goal is to create a prediction-based model on historical data of college football games to predict the winners. Some of the data that was collected was, all the data that was collected was from an API called College Football Database. I used the results from 2018, 2019, 2021, and 2022. I intentionally left out 2020 because that season there was many missed games, and some teams only played like 6 games. so I didn't think it was quite relevant to prediction because it was kind of all over the place. I did filter all the games to be only FBS, which is the top division in football. I was interested in the top division more than the other divisions. It also worked out that the data contained more information for those, more complete data for the FBS school. I filtered out all the NAs from the ELO columns. That is a rating that I'll explain later in the presentation, but was key to the prediction model that I created. Some of the transformations that I did to the data was I combined all those years together into one data frame. I removed all the bad data, bad being NAs in those critical columns for the ELO column that I spoke about earlier, as well as some game IDs, had some alpha characters in there, and I needed full integers. I separated out the testing and training data, and I added a prediction column later in the project to be able to compare and get a percentage of my accuracy for my model. There's a small note here. You'll find that my data that I used to make the model was not as robust as I would have liked. I'll have more at the end about my challenges, but one of the challenges was getting the data that I wanted to work with. Project planning, I used a mind map here to sort of organize myself and keep in order what sort of things I need to be doing in what different categories. Some of the tools that I use, so these are the libraries, right? Someone mentioned tidyverse earlier. These three in the middle here, Tibble, ggplot, and dplyr, are all part of the tidyverse. The CFB fast R was a R group of R functions that I was able to use to interact with the API a little bit easier, instead of having to make these complex calls to the API in a different way outside of R. I was able to do it within R. And then, of course, CFVB is the data source for all my data. It's important to know what an ELO rating is. For these purposes, I used ELO rating as one of the key factors in predicting who was going to win a college football game. This was originally made by a physicist who wanted to get a comparative rating for players, the player skills in zero-sum games, like chess or backgammon. People increasingly have been using these rating systems, the ELO rating systems, for all types of sports. Like baseball's got a lot, and football and soccer all use these systems. And what it is a way to compare the teams, like I said before, their skills, and be able to compare teams over a long period of time, because you're using all the same rating system. And it's all relative, so the seasons can change and still have an accurate rating of it. And that team's rating will go up if they win the game. If they beat a higher rated team, they'll get more points, and the ratings will move down if they lose. So it's an accurate rating that moves to be more accurate as the season goes on. It's especially helpful for sports like baseball, where there's tons of games, but football, it's a little bit harder since there's so few games. So the factors, here's another explanation. So essentially, an ELO rating, you find the difference and divide by 25. So if the difference was between two teams in rating was 250, that team should win by 25 points. The four factors I used in my linear model here was the home points, the away points, that's the home and away teams, the home pregame ELO, and the away pregame ELO. So those are those ratings that I was talking about. Here's the model where I put it together and used the training data, which were the seasons, all the seasons with the exception of 2022. That was my test data. Here's a plot of the actual home points versus the predicted home points for my predictions. You can't see here. I have a couple of numbers in the next slide that will give you an idea of how accurate my model was. And that was 47% accurate. It wasn't great. This root mean square error would be the error in which a prediction may be wrong. So that 12.44 means points. So essentially that means that my model error is 3 scores. So to get 12 points, you need 3 scores in football. So that's not very accurate. In summary, I think additional data with more variety would be needed to get something more accurate. Perhaps the linear regression might not be the best way to go about predicting. 47% is not very good. And if you're going to be like betting or anything like that, or just trying to be right, that's not a good percentage. I was encouraged. I did read an article about someone that did something similar and far more sophisticated than what I did with 60 or 70 tables, and he was only able to get 60% accuracy. My data was about 2,000 rows, maybe 70 columns or so for each thing. I probably should have worked in a group. Thank you, Tushar, for telling me I should have done that. And getting the correct data was harder than I expected. The main challenge was getting the data. And over here on the right, I have the code I was going to use and was real proud of that would have gotten using a for loop from all the game data. The large data set of all the games had a game ID, and I used that game ID to go fetch more advanced statistics from each game that I thought I was going to use in my model. Things like explosiveness per play, success rates, and points per attempt. And I thought I was going to be able to, look at all this stuff and really get something a lot better. But some of the games were missing, and I was struggling to find a way in which, because I didn't know which games were missing. So when I called the database with in my for loop for certain game IDs, it would time out and then throw an error. So the code definitely works. I was able to do it on a small data set where I knew games existed, like 5 or something. But when I was trying to do 2,000 or whatever, I just couldn't figure out a way to find the bad games. And that's all I have.
So first of all, thank you, because you're alone and you have done quite a good job. So give a big round to our friend. He really worked hard, especially fighting with Mac versus WebEx. So that's awesome. Right. So question for you, Christian, when you started this thing, right, you seems like you have interest in football. You started. So as you progressed, like, how did you come to know that I need to use this library? I need to use this library? So
during classwork, I had stumbled upon the tidyverse ones, right? And I found that using those libraries in class, like the DPLYR, I think is just great. Like in my mind, using filter is so much easier than using the braces and the comma, selecting the rows. I just like understand it better. So that's how I knew that one. And then ggplot you had mentioned in class as well. The college football data, this data where they got API, I'd used before because I made a website for people to pick bowl games. It was like a fun thing. So I knew about that, where all that data was. And then I just sort of stumbled upon this R wrapper library for that.
Very good. I hope you enjoyed this exercise, because sometimes working alone is sometimes challenging, but it seems like you did quite a good work here. Again, thank you so much. Any questions for Christian?